Hello everyone. Last time we have done a relationship between the single chiral center. Now today we are going to talk about relationship in multiple chiral center case. So multiple chiral center. So here we have three kind of relationship. One is identical, second enantiomer, and third diastereomer. And again we have two methods. The first RS, second exchange, and here as well RS and exchange. RS exchange. Let's talk about the very first one, identical. RS method. So here we can say both compounds should have same configuration with respect to each chiral center. For example, suppose this is the multiple chiral center, and I am saying here the top one is R, bottom one is S. So this to this chiral center should have same, it means this also R and this one S. Okay. So it should be same with respect to each chiral center. So this kind of relationship is known as identical. The second case, rule for this, exchange. So we can say both compound should have even number of exchange. Even number of exchange. Like this. It means top to top should be even. Bottom to bottom must be even. So this one is called identical. Next is enantiomer. RS. So both compound should have opposite configuration with respect to each chiral center. It means this is R, this one is S. So it should be opposite as S and it should be opposite as R. So this kind of relationship is called enantiomer. Next, exchange method. Both compound should have odd exchange with respect to each chiral center. Like this. This to this odd, this to this one is odd. So this kind of relationship is known as enantiomer because we have odd exchange. The next diastereomer. Diastereomer. So RS, anyone have same configuration while rest have odd. It means If this one is R, this one is S, so suppose this one is same as R and this one is opposite. Oh, sorry, I made mistake here. It should be anyone have same configuration while rest have opposite. It means it is a mixing of both basically. So it should be R. So anyone can have same, rest is opposite, or it is mixing of same and opposite. This is called diastereomer by RS method. Next is exchange. So here we can say anyone have even or no change while rest have what? This is even or no, and this one is odd. So called as diastereomer. So it's quite simple, if you are talking about RS method. So both the chiral center have same configuration in both the structure, then it would be identical. If they both have opposite configuration with respect to each chiral center, then it would be enantiomer. And if it's mixing of both, it means same and opposite, then diastereomer. Simple. And if you are going to apply exchange, if they have even exchange with respect to each chiral center, it would be identical. If they have odd, it would be enantiomer. And if it's mixing of both, even and odd, or even no change with odd, then it is, you can say, diastereomer. Let's do an example. So we have three compound, 1, 2, and 3. And I'm saying what is the relationship between 1, 2, 2, 3, and 1, 3. So let's talk about 1 and 2. So let's apply exchange rule. So look at this top and this top chiral center. How many exchange between them? So if you look at the very first, chiral center, Br in the left, Br in the left, and there is a mutual exchange between OH and H. So this is odd. Now figure out in the bottom one, chlorine left, and there is exchange between NH2 and CH3. You can see. So this is again odd because one exchange in the top, one exchange here. So both are odd. Do not add them like top odd, bottom odd, so odd plus odd is even. No. Always consider one on one, means this top to this top, bottom to bottom. So both are odd, it means enantiomer. Now second and third. So we can compare this top to this top. How many exchange? Br in the left, Br in the right, OH on the right, OH in the left. So you can see this is the exchange between OH and Br. So this is 1, 1 means odd. Now look at the bottom. Chlorine left, NH2 bottom, NH2 right, CH3 down. Okay, this is another one, so odd. And again enantiomer. Now 1 and third. So if you look at 1 and third, how many exchange between top to top? So Br in the right, Br in the left. You can draw like this. If you look at the first compound first, the top chiral center, this is OH, this one is H, this one is Br. Bottom one is this carbon, so you can keep carbon. Here the third one, the top chiral center is here Br, here OH, here H, carbon. Now you can compare here, okay? So bromine is here horizontally, right? So if bromine goes here, H goes here, draw this. Now my Br is fine, and then you can compare OH with H. So you can see OH and H. So overall 2 exchange, and also odd plus odd produces the third compound. So this is odd plus odd, it means 1 plus 1 is 2. So top to top is here even exchange. And now look at the bottom one. Bottom one is exactly same, you can see NH2, CH3, Cl. No change. So this is identical, okay, because both have even or no change. Top is even, bottom is also same thing. So it's identical, okay. Identical. So this is the way you can figure out the relationship between the multiple chiral centers. Now we are going to deal with the terms like plane of symmetry, optically active, optically inactive, meso compounds. So first talk about optical activity and inactivity. Suppose we have an ordinary light, and when this light, ordinary light we have, and when this light is passes through a Nicol prism, it come in a plane like this, converted into PPL. This is called PPL, which is known as plane polarized light. And when this light is passes through a solution, optical solution, then it can show three kind of behavior. It can rotate the PPL either clockwise, it can rotate in anti-clockwise, and there is a no rotation. So whenever no rotation, that is called optically inactive. Optically inactive. And when there is a rotation, that is called optically active. Optically active. So these are some terms, okay? Now the next is plane of symmetry. Plane of symmetry. So what is plane of symmetry? So we can say it is a hypothetical plane. Hypothetical plane which can divide the molecule in two equal parts. Two equal parts. Like this. Suppose we have this compound and now it is divisible into equal half. So we have a plane of symmetry. So whenever we have a plane of symmetry, that particular compound is known as optically inactive. And optically inactive compounds are achiral in nature. Achiral. Okay, so sometimes they can give you some other compounds and you have to figure out which one is a chiral compound, which one is a achiral. So this is achiral. Plane of symmetry, you can, figure out here as well these kind of compound. You can see it is divisible into equal half. So we have again plane of symmetry. Now the next is meso compound. Meso compound. So for meso compound, we have two conditions. The condition one should have at least two chiral center. Should have at least two chiral center. And second, must have plane. You can see basically must have. And here must have plane of symmetry. This one. OH, H, CS3, CS3, OH, H. So you can see we have a two chiral center and plane of symmetry. So this one is a meso, and meso are optically inactive. Optically inactive. Okay. And one more thing I would like to tell you, a note point. Whenever any compound have exactly one chiral center, then that compound would be optically active and also called chiral molecule. Okay. So means if you have just one chiral center in any compound, it means that can never have a plane of symmetry. Okay. So we can do some of the questions and look at this one. And there is a one more, symmetry. This is the plane of symmetry. There is another symmetry which is called molecular plane of symmetry. For example, suppose we have this kind of thing. Like this one, suppose we have. Suppose you can keep any atom here. And I'm saying what kind of symmetry we have. So look at what is molecular plane of symmetry. So whenever you have a carbon which is sp2 hybridized, this carbon is sp2 because of double bond. So sp2 hybridized carbon is a planar carbon. So planar means this is the plane. And now I'm going to cut like this axis. Okay. So if you are going to cut from here, you can see the top and the bottom one is exactly same. You can assume like that. Suppose this double bond is in this way. Okay. And you can assume all the four atom as a atom structure, just like a ball. Because they are all lie in the same plane. So if you are going to cut like a slice cut, you know what is slice cut? Just like this pen, and you are going to cut like that. So if you are going to cut the molecule like here, this is divisible into, this is divisible into, this is the divisible into, and this one as well. So this one has molecular plane of symmetry. Molecular plane of symmetry. Okay. So generally a planar compound have that kind of symmetry. Now look at this one. And my question is, what is the nature of this compound, optically active or inactive? Optically active or optically inactive? So I would like to tell you, whenever any compound have just one chiral center, then it would be optically active always. And you can see there is a more than one chiral center you have, this one and this one. Okay. These two are the chiral centers. If you are going to say. Now, the second thing, you have to figure out the symmetry here. So if you are going to cut from this axis, you can see the left and the right is exactly same. It is divisible in 2 equal half. So this is a plane of symmetry. And whenever we have a plane of symmetry, it means optically inactive. Okay. It makes sense. Perfect. Now we can try this compound as well. And one more thing I would like to say, if you are going to pass an axis, suppose this, then do not compare this and this, because it doesn't make any sense if it is wedge or dash, because this atom is divisible into equal. Suppose this wedge carbon is bonded with the atom of ball, and this like this. So once you're passing through a axis, then it is going to divide this half here, and half here, the top and bottom. So there is a plane symmetry here as well, okay? So this is divisible into equal half. You can see the left and right is exactly same. Make sense? Okay, let me give you some more question based on like chiral, achiral, and what about this one? So first question is, what is the nature of this compound? Chiral or achiral? Chiral or achiral? Or even I can say optically active or inactive, simple. So let me tell you, whenever I am saying achiral, it means there should be a plane of symmetry. Okay, first question is, they have chiral center, yes or no? This is CS3, this is OH, but left and right is exactly same till the end, you can see. So there is no chiral center here. There is no chiral center. And whenever there is no chiral center, that means compound have achiral. Okay. Whenever there is no chiral center, it means it is achiral. Clear? Okay. What about this one? So again, first thing is to figure out number of chiral center here. And yes, we have two chiral center, and I told you how to find out the chiral center in a ring. Okay. I have discussed this already. So we have two chiral center here. Now, second thing is that if they have two chiral center, they have the plane of symmetry, yes or no? Please tell me. No, they don't have plane of symmetry, okay? So whenever you have a chiral center, that means compound is chiral. So this is chiral, okay? And if there is no chiral center, then achiral. Clear? In group session, I will discuss more about it in form of a question, okay? So I would like to give you another one. Suppose we have okay, we can try this one. Let me give you a question like relationship question. Okay, we can switch this and this like that. Okay. What is the relationship between them? So as you can see, we have two chiral center. If you look at the top one, can you see this? How many exchange? No exchange. How many exchange here? No exchange. So this is identical. Okay. What about this one? Okay, what about this to this? You can see this is in the left, this one is in the right. So there is a one exchange, one is an odd. This is right, this one is left. This is again one exchange, odd. So odd and odd means enantiomer. And also you can see this is just a mirror image, non-superimposed. If you can keep a mirror here, it's just a mirror image of this. So 1 and 2 have non-superimposable mirror image. So this is enantiomer of each other, okay? So this is about optical activity, optical inactivity, relationship in the multiple chiral center, chiral and achiral, okay? And also plane of symmetry. So in the next video, we are going to talk about the chair form of cyclohexane, how to convert the Newman into Shahar's projection. So these kind of conversions. And I think that would be the last video of this stereochemistry. Thank you so much.